Well, yes, we get to finally solve two-step equations. This is one of my favorite things that I get to teach. To do this, you will definitely need a calculator today. So if you haven't already pulled one out of your resources, do that. Of course, you're going to need a pencil. You're going to have 2 pages for this. You're going to have a little strip here that has some higher order problems with rational numbers that I'm going to work with you slowly so that you know how to handle when you have fractions and decimals and such. And again, that's why we would need our calculator. You also will have your paper that looks like this. This half part is upside down. And then you have the examples here. It'll say examples along the bottom, and basically it will fold down. You would cut here to reveal the examples. Now I'm going to give you a heads up. You're going to want to make sure that you can cut here without cutting off these problems at the top. So the paper that I have wasn't copied well. So if I'd actually had cut on the line, I would have cut into my problems. So I made sure that was the case. I also trimmed alongside the edges of my problem set so that it would fit like this. And then I glued this right underneath it because you will need the space underneath to work the problems. So again, I also encourage you to really participate in the video with me, pausing the video, working the problems out. I'm telling you, it makes all the difference in the world when it comes to understanding what we're doing here. So I've already glued mine in, and so that's going to make it a little bit difficult for me to write. So I kind of wish I hadn't done that. But let's talk about the steps. First, we have the steps 1, 2, and 3 that just set up the problem. And that's where you're drawing a line down the equal sign and a total line and bringing down your equal signs. That just separates the 2 parts of the equation. Boxing the side of the equation with the variable, we do that so that we can isolate all the things that we are working on moving out of the box to get the variable by itself. And then circle and bringing down your variable and its multiply and divide partner. This multiply and divide step is usually the last thing that you're going to do unless you have parentheses. And so we're just going to isolate it for the second step. So I'm going to show you what just the setup looks like. In this problem, separating the 2 sides of my equal sign, drawing my total line, and then this will be my 2 equal signs for my step 1 and my step 2. And I can do this for pretty much all of my problems ahead of time. It can really jumpstart your brain into understanding what am I going to do. And now this one has parentheses, so it will be a little bit different. So I've drawn the separation between both sides of my parenthesis of my equal sign to show the 2 sides of my scale to keep it balanced, a total line for my add and subtract if I'm going to do that first, and then bring down my equal sign. So see how easy that was? Now let's go back and talk about when we're solving equations, we're doing PEMDAS in reverse, trying to get the variable by itself. And so PEMDAS, you would normally start with parentheses, then exponents. That's this third step. Not very often will you have parentheses. I think I have an example problem here with parentheses and here, but most of the time you will not. And then you would, after parentheses or exponents, you would multiply and divide, then add or subtract. So to do it backwards, we're going to actually start with the add and subtract. That is why we draw a total line. So let's work these problems out. You can see here, I have 2x minus 5 equals negative 17. So I've already set it up. I'm going to do my add or subtract. But when I box it in and finish setting it up, what's left in the box I need to get rid of? I've already brought out my 2x and brought it down to deal with later. So I have this minus 5. The opposite of or inverse of minus is add. So minus 5 plus 5 cancel out. But if I add 5 to this side, I need to add 5 to that side. You know your integers, different signs mean I subtract, keep the sign of the bigger number. Now I have my multiplication step. What's the opposite of multiply? Divide. 2's cross out, leaving my x, and negative 12 divided by 2 is negative 6. I love doing these. I could do these all day long. So let's box this in and bring down whatever my variable is multiplying or dividing. So here I will do x divided by negative 3, and I'll deal with that later. So now all I have left in my box is this plus 4. How do I get rid of plus 4? That's right, minus 4 or negative 4, however you like to think of it. 3 and a negative 4. So that's a positive 3 and a negative 4. When my signs are different, I would subtract the absolute value and get 1. And then, which had more? The negatives. So be negative 1. But over here, I have x is divided by negative 3. So the opposite of divide is multiply. So I'm going to multiply by negative 3 on both sides. Those cancel out to leave just my x, and negative 3 times negative 1. Sorry, negative 1 times negative 3 is a positive 3. Nice. All right. Hey, I challenge you. Why don't you pause the video, see how far you can go on your own, and then see if you're right. Here we go. I'm going to box this in, bring down what's with my variable, its partner. That's what I mean when I say to circle and bring down your variable and its multiply or divide partner. See, here was my variable, the x, and its partner is it's being multiplied by the 3. So I've gotten rid of that. Now I need to get rid of plus 4. So subtract 4 from both sides. 1 minus 4 is negative 3. How do I do the reverse of 3 times x? Divide by 3 and get x is negative 1. Yeah. Okay, so I've gotten my first problem that has a little bit of difficulty, and that is because I have a decimal. So you would bring down your x. You can see I still need to get rid of this minus 2.8. So I'm going to do the opposite and add 2.8. 9 plus 2.8. See, that wasn't so bad, was it? 9 plus 2 is 11, and just have your 0.8, because this is like a 0.0. I'm just adding that up. You could use your calculator. And so since there wasn't a variable in front of 1, this is already a ghost 1. So 1x is 11.8, or x is 11.8. That's it. Finally, I have something here with parentheses. So let's look at this. Perform my add or subtract steps. If you look at this, I have a number being multiplied to my parentheses, but that has to stay together. So I don't really have any add or subtract that I can do independent, because the addition step is inside the parentheses, and I have to leave my parentheses till last. As you can see here, no independent add or subtract. So I need to move on to my next step of multiply or divide. Well, I have this 6 that's being multiplied. So I'm going to divide both sides by 6. And I'm going to bring down my parentheses of n plus 3 equals, and negative 6 divided by 6 is negative 1. So now that I have just my parentheses, I did not have an add or subtract. I already did my inverse of multiplication, which was division. So now I'm going to perform the inverse operation within the parentheses, which was an addition. So now I can subtract that out. My n is down here. That's gone. A negative 1 plus a negative 3 is a negative 4. How about we skip straight over here to number 8, which are similar problems, and let's do that. And let me tell you, do not rewrite the problem putting your expression on the left and your solution on the right. That's really going to come back and bite you when we work with inequalities. So we're going to do just this problem. We're going to first divide by 4 and bring down our a plus 6. Negative 2 divided by 4 is negative 1/2. Then I'm going to subtract 6 from both sides and get a equals negative 1/2, and negative 6 is negative 6.5, or negative 6.5. All right. So we did this problem and we ended up with the A being 6 1/2 or negative 6.5. Both of these, of course, are saying the same thing. So that was how we work the problems with parentheses. Let's go and talk about this one, which has decimals, and this one, which is pretty straightforward. I'm going to box everything with the expression, bring down my variable with its multiply and divide partner, and then look at what's left in the box to get rid of. If this has already been brought down, I need to get rid of this negative 5. What's the opposite of negative 5? Plus 5. You could also say the opposite of subtract 5 is plus 5. Whichever way, that's how you get rid of that. But if you add 5 to the left side of our balance, we need to add 5 to the right side. 6 plus 5 is 11. Now, still need to get b by itself. So how do I get rid of divide by 4? I multiply by 4. But I've got to do it on both sides. And putting 4 in parentheses like this means to multiply, the same as putting a dot by 4. It both means multiply. And 11 times 4 is 44. And the last problem in this set has this with decimals. Box in whichever side has the variable. Find its multiply and divide partner and bring it down. The whole multiply divide with the variable. So that got rid of this. So what's left in my box to get rid of is minus 1.5. So I'm going to add 1.5. But if I add it to the right, I've got to add it to the left. So this is gone. So I still have this. So here my signs are different. I have negative 6 plus 1.5. It's kind of like saying I owe $6, but I put $1.50 on it. So now I still owe money. It's still negative, but now it's only 4.5. Or you could just take 6 minus 1.5, and I'm going to subtract because signs are different, and then take the side of the bigger number. Now, how do I get rid of this? A number right next to variable means multiply. So the opposite of multiply is divide. So I can get y by itself now. And 4.5 divided by 1.5, you could put that in the calculator and you would get a perfect 3. However, a negative divided by a positive is a negative, so don't forget your signs. Awesome. So we have now completed all problems 1 through 8. So you have a good set of examples, but I want to talk to you about these more difficult problems. They're multiple choice. They come from your accelerated math. And so I'm going to kind of separate the 3 problems here. I'm going to rewrite the problem. You should always do that because we need to work on it. Bring my equal sign down twice and draw my total line. Box in, bring down my variable and its partner. So I have p divided by 2 here. So here I need to get rid of negative 7. I'm going to add a positive 7. Let me add it here and it becomes plus 7. So a negative 9 plus 7. Signs are different. So I'm going to subtract, keep the sign of the larger number. Now I'm having to deal with the second step. My number, p, divided by 2. Well, the opposite of divide by 2 is times 2. So I get p, and then 2 times negative 2 is negative 4. So my answer is negative 4. Now this problem could very well give us a lot more trouble because look at that fraction. But we're going to work this together, and I'm going to remind you of all the tricks I've already taught you. Let's bring down our equal signs. Box in the side with the variable and bring down the variable with its multiply divide partner. I see plus 2, so I'm going to do the opposite of add 2 and subtract 2. 11 and 4/5 minus 2, I can just subtract the whole numbers and get 9 and 4/5. Now, there's 2 ways to solve this problem. And normally, some of you would change 7/10 to 0.7, and 4/5 you would put probably 9.8. But when I look up at my answers, I see that some of those answers have fractions in them, and I'm going to work hard to leave all the fractions alone. So I'm going to say this number is being multiplied by v, so I'm going to divide by 7/10. And I have taught you guys, I have a tear in my paper, you'll have to excuse that. I have told you guys that dividing fractions is the same as multiplying by its reciprocal. So I'm going to bring my v down. But what's going to happen here is I'm going to multiply by the reciprocal of 7/10, which would be 10/7. However, I can't multiply this while this is a mixed number. So I'm going to say 5 times 9 plus 4 to get 45 plus 4 is 49. I'm going to have 49/5 times 10/7. I just changed this mixed number into an improper fraction. So now I can say 5 and 10 reduce, 7 and 49 reduce, 7 times 2 is 14, 1 times 1 is 1, and look at that. It turned into the whole number 14. So you probably could have changed that. You could have said 0.7v equals 9.8 and just divided by 0.7 with your calculator, and you would have gotten 14. All right, let's look at the last problem. It's actually not as hard because decimals are so much easier to use because you can just use a calculator. So I'm going to write my problem. Plus 0.6 equals 18 and 534 thousandths. Ugh, that sounds kind of gross. I'm not afraid of no decimals. Here we go. Box in the side with the variable. Circle my variable, whatever it's working with here. It's being multiplied by 1 and 47 hundredths. Get rid of this 0.6 or 6/10 by doing the opposite. So I'm going to subtract 6/10. You could add extra zeros and just do it with paper here. Or you could have used your calculator. There's either way. Now, I'm not going to do that without a calculator, that's for sure. This next step, you know what we've got to do. This number is being multiplied to my r. So I'm going to divide both sides by 1 and 4/7. I can get r to itself now. Let's get the calculator in on this. We're going to say 17 and 934 thousandths divided by 1 and 47 hundredths, 12.2, or 12 and 2/10. And there it is. What? I love math. Awesome. These were some challenging problems here. I'm super proud of you if you really worked them out with me and stuck with it. You will have to do a problem like this on your test. So I hope you've got this zoomed up. I hope you understand each step and that you can use this as an example on your quiz. And all together, be sure that you have put your number on your page and filled out your table of contents. All right. Favorite thing to teach. There it is. Two-step equations. You guys did awesome.